For the longest time, Moore's law continued to speed up processing year by year, and during this time, we got sloppy. Larger and larger software systems were being written in interpreted scripting languages. Systems languages were considered too slow to develop in, and too hard to learn. However, with Moore's law at an end, a new generation of systems programming languages have been getting attention. These promise both developer and runtime efficiency, as well as reliability. But there's just too many of them, and for some reason, Python and JavaScript keep getting popular anyway.
As we all know, independent projects seem good in principle, but ultimately, they're just a waste of resources. I'm excited to announce that several systems language designers are teaming up to make one new language to rule them all. We call this language Systems Upon Systems, or SUSlang for short, and today we want to give you a sneak peek of what's coming. I think you'll be as excited as we are. We're only in on Sus, and those of us here today have put aside our other project work to focus 100% on Sus going forward.
First of all, we know the most important aspect of any programming language is the syntax. Semantics, they really don't matter. It can work this way, it can work that way. Who cares? What matters is how does it look on the surface. So let's talk about curly braces. We got them. But we also got white space. And we also have, an end keyword and a begin keyword. It's all good. You can also spell end backwards, so DNE. You can also spell begin backwards. SUSlang supports all of these syntaxes. So no excuse if you don't like the syntax, because it does support the syntax that you want. It supports all of them. This language is a compromise among all of us language creators, and we've arrived at something that we're happy with because we've put our differences aside and we just allow any mix and match of anything you want. I mean, you can even just do an open parentheses followed by an ending curly. You can put a semicolon in front of your statement. You can put a semicolon after your statement. It doesn't matter. Every syntax is great. Just mix and match whatever way works best for your team.
Of course, with the end of Moore's law, we're happy to say that SUS emphasizes parallel execution. It makes full use of your CPU and GPU cores, and those of your neighbor with the pwning module that's built into the standard library. The SUS compiler also generates a novel execution model that reconfigures your CPU cores as an extension of your GPU with maximum throughput. In all of this, SUS guarantees bug-free concurrency and parallelism. Flip your bits when, where, and how you want to. SUS takes care of all of the mess.
Digging further into language features, SUS is dynamic like Ruby and static like Crystal. And how does it do that? By using a novel testing mode, SUS will interpret your code while at the same time compiling it. Who will find the error first, if the interpreter or the compiler? Let's SUS find out. And when it comes to its incredible performance, SUS beats C++ in a majority of benchmarks while having automatic memory management. It does so with a brand new technique called garbage injection, using static analysis to inject additional memory allocations at runtime to probably improve execution speed. And SUS's approach to functional programming will certainly make the headlines. Perhaps you are aware of how Haskell managed to encapsulate the side effects of your code in a monad. However, systems programming is all about side effects, so we decided that we want to do the exact opposite to Haskell and instead encapsulate the pure code in what we call a unicornad. If you have a unicornad, you know there's no danger coming from it.
Finally, migrating your current codebase to SUS couldn't be easier. Just rename your original file to have a SUS extension and it'll work. Your code will keep the same meaning that it had before. It is an easy sell to management and it looks great in a pull request. In fact, we expect SUS to be used for a very long time, perhaps even exceeding 2 years. After which, of course, we expect most software will be written by artificial intelligences, probably in a language of their own design. But until then, SUS is the best you can get. So what are you waiting for? Well, of course, except for SUS to be released. Choosing a programming language used to be a really difficult process, but now it's easy. Because SUS is the objectively best language for any purpose, there is no choice anymore. In the words of Randall Munroe, we need to develop one universal standard that covers everyone's use cases. Well, SUS is that standard. So what are you waiting for? Come on, we hope you'll join us.